Now, I want to move on to a new topic today, and we look at it next week as well. I think we'll cover most of it in the 2 sessions, if I can anyway. So if I go over to Moodle, the new topic is version control or source control management. And we're just going to walk through a set of slides. I have at least a second set of slides that I need to get through as well, but that'll be next week, I'd say. And then there's about 3, maybe 4 labs. Not 4 lab sessions now, but 4 pieces of work that I'll need you to work through over 2 weeks, I'd say, probably. So I'm just going to walk through the slides that are up on Moodle. Okay, so the topic, as I said, is version control. It's also referred to as source control management. Terms are used interchangeably. And let's see, sorry. Essentially, what we're going to be talking about is the Git tool, although there are other source control tools out there, but Git is by far and away the most popular of them at this stage. All I'm showing you on this slide here is a website of a free book. Now, I don't want you or expect you to go reading chapters of this book, but it's just there as a reference. And it's, even though it's quite an old book, it pretty much has everything that you need to know about Git. So maybe sometime in the future, if there is something particular that you want to read up on a little bit and get a bit more information on in relation to Git, then that's a pretty good source. But as I say, I don't really need you to go accessing it really. What is version control? So I'm saying it's a system that records changes made to a set of files over time so that you can recall earlier versions. So essentially, it keeps a log of all of the changes that have happened to a set of files within a project. By the way, it doesn't have to be a source control project. It can be any folder, essentially, that contains subfolders and files within them. They can also be subject to Git control or version control.
这个直接跳吗
？Slack 里有。
这个华为它没有
Somebody has their
它没有谷歌
995那个。
Somebody's got their microphone turned on, so if you could mute yourselves, please. Now, why do we want to keep a record of changes that have happened through a set of files? These are possibly the reasons. So that we can essentially kind of rewind a set of project back to an earlier date.
爱丁堡呢？也不是那个爱丁堡的
Sorry, no. Somebody has got their microphone turned on. Can you turn them off, please?
我知道，那个是不是
就是冷门
社科院？
就是冷门的
社科院的社科院那个数据科技
冷门专业。
明白啊。
Right. These are the reasons why we might want to do version control at all, to rewind a particular file or a group of files or the entire project back to an earlier date. To check something, presumably, maybe if it's source control, if a bug has been introduced, then we want to try and get back to a state where things were working. What else? Also, what's really nice about Git is that you can compare different versions of a file. And number 4, then, it'll also, what it does is it records who changed a particular file, where in the file was it changed, when was it changed. Now, the only thing I didn't mention here is the why. The why is very important as well. I should really have included it in this list, but maybe you can edit that in yourselves. So it does all of that for us for free. version control is also called source control, I'm saying down here. And as I mentioned at the outset there, okay, source refers to source code, but we use version control tools now for other types of projects as well. And the real reason that version control tools, even though they're very useful when you're just working on a project on your own, the real benefit is if you're working in a team. So they're really great to facilitate collaboration between team members, because certainly in an agile software development environment where our code base is changing constantly and rapidly, then it's really important to essentially keep some sort of control over the changes that are happening to a file. You can't stop people from making changes to source code. That would defeat the purpose of having teams at all. But we do want to know when files are changed, why, where, etc. And that's what Git is great at doing. Now, version control as a topic kind of has been around for quite a while, so it predates Git. And in the earlier kind of incarnations of this whole topic, the version control system itself was very much kind of centralized, and that's what I'm kind of getting across here. So there was a server, and it was on the server is where your repository resided. A repository is nothing other than a database, really. It's not a relational database, but it is a database. So the server was the only place where our repository resided. You couldn't edit any files in the repository. What you did, as you probably know now at this stage, is what you did is you got a copy of a particular file onto your own local machine. You made the edits there, and then you updated those. You pushed or updated the file on the central server to make sure that the repository was more up to date. So that was kind of the earlier versions of this source control tool. So that's what I'm saying here. It runs on a server, and that's where your kind of master copy of your repository resided. This is not, now don't think of this as GitHub. I'll talk about GitHub briefly in a few moments, but this is just a server in the everyday sense of a server. But you can see that the individual people that are working on this project, you know, they can only have a copy of a file or files which they have retrieved or downloaded from the central server, done some editing, and then pushed their updates back up to the server. And so the kind of earlier forms of this version control tools, there was a tool called CVS, which stood for Concurrent Versioning System. Subversion was another one, Perforce, etc. So they were all based on that kind of model. Of course, the disadvantage with this model is if the server, for whatever reason, is down or inaccessible, then nobody can work on the project. But still, some of the concepts that existed back then, those concepts still apply today. On the next slide, I have essentially the same model now. So this is the server in this case. This is what my repository. So that term repository is still being used today, even though we don't use these centralized forms of version control tools. And we have the notion of individual team members then. What they do is what we say is they check out or get a copy of a part of the repository. It could be the entire repository, you know, the entire project, or subfolders within it, or individual files. Their local copy we refer to as a working copy or a working area. And we use that term when we're even talking about Git. So we have this notion of working area, working copy, repository, the notion of checking out or getting a copy of something from the central repository. Typically, you make edits here, and then you push your edits or commit your edits back to the central server, and it takes care of making the relevant updates there. so that the term repository, working copy, working area, commits, push, pull, all of those terms apply in a centralized VCS system. Moving on then to a distributed VCS system, which is really what Git is. In a centralized version control system, you can see on the right there, every single person has a full copy of the repository on their local machine. Now, one of the machines in this network is nominated as the master, and it can be any one really. And so if the person working on this machine makes some changes to the repository locally, you know, they make some edits. They don't make edits to the repository directly. They still have to check out or get a copy of some content, some part of the repository, do the editing, and then commit that locally to their local repository. But once the repository here changes or is updated, it notifies the other nodes in the network about the update to the repository. That's going on behind the scenes. The user doesn't have to worry about the kind of networking that's going on. But that's how these distributed or decentralized version control systems work behind the scenes. So on the left, I'm saying, yeah, everybody gets a full copy of the repository. One node is deemed the master. If that node goes down, then one of the slaves is nominated as the new master. That's how Git works. And there's also a tool called Mercurial, which works the same way. Now, essentially what we are doing is, and what you are doing is, you're using Git on your local machine, but there's no network of nodes involved at all, right? And again, don't think of these as kind of GitHub. GitHub is very different, and I mentioned GitHub here, but this is the way that you will be using Git in this module, and this is the way that you've used Git if you have used Git up to now anyway. You use it in a kind of standalone form. Now, enter GitHub then. All really GitHub is, I'm saying, is that it's a cloud service that provides provides a variation on the distributed idea, but really all GitHub is a backup of your local repository. So you make changes to your local files here, you commit them to your local repository, and then every now and again you push this repository up to GitHub. But so think of GitHub as nothing other than a backup copy of the local repository on your machine. Now, okay, GitHub has some nice collaboration related features as well, but originally that's all GitHub was and still is really. So we are talking about, from here on in now, we're talking about using Git in a standalone form. And so when you've got a project on your local machine and you create a Git repository for that project, as you may or may not know, what a Git repository, how it actually materializes in your file system is there will be a folder within the project called .git. And if we expand and look inside that folder, we see what's here on the right. Now, you never need to really go looking inside the internals of a Git repository. And you certainly shouldn't go making changes to the internal parts of a Git repository. But that's what it is, right? That's what it looks like. Later on, we will actually take a look inside it, so we have some sort of sense of as to what's going on inside there. Now, so on the left here, there's my Git repository for this particular project. And this project looks familiar to us. It's that little catalog project. Now, when I talk to use the term working copy or working area or working directory, then this is the working directory in the context of this project, because we can make edits to these files here. And after editing, then we may want to commit the changes that we've made, commit them into our local repository. So this is our working copy, working directory, working area. Right. So physically, that's what a repository looks like. A Git repository looks like from a folder and folder sense. So to get started using Git, and I'm assuming people actually know this already, this is the command that you use to create an empty repository. Now, when I say it's empty, when you type this command and hit return, you know, all of these things, there's quite a lot of files and folders that make up an empty repository. It's only empty in the sense that it doesn't have any copy of your working area yet. So Git init will just create the repository, and I'm saying you must run this command to make sure you're always in the base folder of the project itself when you run this command. And then to actually make an initial copy of your working area and put it into the repository, then there's two commands that you have to submit. There's the git add command and the git commit command. We'll distinguish between these two commands a little bit later on, but there are two commands. So once you've completed these two commands, you now have essentially an initial version of your working area inside in the repository. So we can refer to that as version 0 or version 1, it doesn't really matter, but it's the first version of our project that we have stored now inside in the local repository. Repository storage, just a little bit about this. Again, this slide is more looking back. In the earlier types and the earlier version control tools, for example, VCS and PowerForce, the way they stored your files in the repository is demonstrated here. So let's supposing I've got this project and it has 3 files in it. And let's suppose there's some initial content in those 3 files. And so I do a git add and a git commit. In other words, I do these 2 commands here. And I now have the first version of my project stored inside in my repository. Let's supposing I then make some edits to file A and file C. And having made the edits, I then do these 2 commands again. Now, the way version control tools used to work is what they saved inside in the repository were the changes that you have made to the files, or the deltas as they're called. And that's what I'm representing here and here. It's storing the changes, the parts of the file that you have changed. So now I have 2 copies of my project in my repository, the initial one, and essentially this one. If I want to recreate this one, I have to, well, not I, but the particular tool itself, it takes the initial file, then makes this change to it, takes the second file, doesn't make any change, takes the third file and makes that change. So it has to essentially recreate or rebuild the project for you. I then go along and let's say I make a change to file C and I do a git, I commit those changes to the repository. This is not how Git works, by the way. But the point I'm trying to get at here is that the way these tools used to work is they just stored the deltas or the changes to the files as you kept on updating the repository with changes to your project. Whereas Git is different. This is how Git works. So same scenario, I've got 3 files initially in my project with some content in them, and I have git added and git committed those to my repository. So I've got my version 1. I then make a change to file A and file C, and I do a git add and a git commit again. But this time what Git will do is it will change the entire, or sorry, it will make a a copy of the entire updated file A and file C and store those in the repository. For file B, it'll just contain a reference back to the original file B. And so on it goes. So it's now actually, what we say is, it's each time you commit to your repository, and I think I say it up here, Git takes a snapshot. I use the term snapshot here. It takes a snapshot of the entire working area and copies that snapshot into the repository. So if you like, this is a snapshot of my project at one stage in its evolution. I've got a completely new file A, completely new file B. File C didn't change since the previous commit. So it essentially kind of keeps a reference to the previous file C. So it's this idea of taking a complete snapshot of your working area or your working copy or your working directory. That's what Git actually does when you do a Git commit. Whereas if I go back to the previous screen, it was very different in the earlier types of version control tools. Git never worked like this. Okay, that's just, by the way, more so background yet again. So I talk about the working directory there, which is where you do your edits. And I'm saying on this slide that the status of your working directory is either one of the three on the left here. It's either in a committed state, which means that the repository has the most up-to-date copy of the working directory in it. In other words, you've just done a commit. And so now the repository is in sync with your working area. So we say the working area is in a committed state. Alternatively, the working area could be in a modified state, which means you've made some edits to some files and you haven't committed them yet. And the third one, which is the kind of odd one really, your working directory could be in a staged state. And stage, which is a bit peculiar until we look at using Git, it'll make a little bit more sense then. Staged means you have made some modifications to some files. You've told Git about those modifications, but you haven't committed them yet. So essentially, when you do the git add command, your working area is now in a staged state. It's only when you do the commit command that your working area is in a fully committed state. Okay, it's a bit odd, I know, but maybe when we start looking at Git in a little bit more detail, it'll make a slightly more sense. So I'm saying stage means that the changes in the working area, okay, I'm phrasing it here by saying they're ready to be committed, but they haven't actually been committed yet. And the diagram on the right then is kind of showing you how you transition from one state to the next. Note now we're talking about the status of the state of the working area. So this is your typical workflow. You create your project structure, whatever you're working on. There may be some boilerplate files in it. So you create that. Then you create essentially an empty repository using the git add command. Then you add that initial project to your repository. You stage it first using the git add command. So the git add command now moves our working area into a staged state. Then you issue the git commit command, and now there is an initial version of your working area inside in the repository. We can call that version 0. So the working area and the repo are now in sync. And then what happens after that is, as you imagine, you make some modifications to files in the working area, you stage them, you commit them, and on it goes within that, within this kind of loop here afterwards. Now I am saying down here that if you're familiar with Git at all, we're not using branching at all here, but we should be using branching, but I'll talk about branching a little bit later on. Now, I'd imagine all of this so far is pretty familiar to you if you've used Git to any degree. Now, I talked about the status of the working area there, but if we look at any particular file in the working area, its status can be any one of 4 states. Okay. When you add a new file to your project, let's supposing we have created our project initial structure, and we have staged and committed that initial structure into the repository. Let's supposing I then add a new file to my working area. Now, from Git's perspective, that file is categorized as untracked, which means essentially it has no knowledge of that file so far. There is no copy or version of that file in the repository. So the term we use is that file is untracked. Now, more than likely, the next time you do a commit, it will include this untracked file. And now Git does know about it. But initially, it's categorized as untracked. An unmodified file is a file that Git does know about. In other words, there is a copy of it in the repository. It may not be the most recent commit. It may be an earlier commit, but there is some, if you look back through the commit history within the repository, there is a version of that file in there, but that file has not been edited since it was committed, whenever it was committed. We categorize that from a status point of view as being in an unmodified state. So it's tracked, but it hasn't been modified since it was committed. A modified state means that you have made changes to it in the working area and you haven't committed them yet. And finally, our friend, the stage state, means it's modified. You have told Git about it using the git add command, but you haven't committed it yet. So it's in a stage state. Again, it's a bit woolly as to what this might mean, I know, but so just be familiar with these terms: untracked, unmodified, modified, staged. This diagram then shows how any file within your working area moves from state to state. So again, if we just imagine we've got a file that's in an untracked state, so Git doesn't know anything about it so far. There's no earlier copy of this file in the repository at all. So it's untracked. If we do a Git, let's see, sorry. If we make, sorry, no. Oh, sorry, unmodified. Sorry, let's go back again. Unmodified. Unmodified means the file, there is a copy of this file in the repository, but it hasn't been edited since we committed it, whenever we committed it. So it's in an unmodified state. If we make edits to that file now changes to a modified state. If we then do a git add on that file moves into the staged state. And finally, if we do a git commit, then that file goes from being in a staged state back to untracked, and it kind of stays within this loop here. That's the untracked. Then on the left is that case where you just add a new file to the project and you haven't committed it at all yet. That's what untracked means. Okay, let's put some meat in all of this stuff. This git status command tells you the status of all of the files in your working area or individual files. Now, what I'm showing, let's suppose we've got this situation where we've got our catalog project and we've made some commits, but after a particular commit, I'm saying we modify this file and we add this file. So let's actually simulate that in VS Code. So I've got my actual, I've got my project here, and it has only one commit, but I can tell from looking, see the really nice thing about VS Code is that it's got excellent integration with Git. And so we very rarely need to submit any of the Git commands from the command line. We can actually use VS Code's Git integration to help us. So what do I mean by that? Let's so based on my slides, I'm saying, supposing I edit product catalog and I edit product.js and I add the test file into my repository, into my working area. Because at the moment now, if I open up the test folder, there's nothing there, and the source folder has these two files. So let's make some edits, and the nature of the edits doesn't really matter now, right? So I'm just going to uncomment that line. And notice on the left now, when I save the file, you see the M here? M means modified. So I can now say that this file is in a modified state from Git's perspective. I'm also going to edit this file. I think I just commented out something at the bottom, so I'll uncomment this. Save it. Okay, that's also in a modified state now. Any of the other files? That file shouldn't be there. I thought I took that file out. Just give me 1 second now. Okay. I'm actually gonna, let's go back actually to here. And so this is the base folder of the project that we're looking at, but there's no .git. How come there's no .git folder here, which there should be, because there is a Git repository. And the reason there isn't, or the reason you don't see it, is because, as you know, any file that begins with the dot character, that's a hidden file. And so I have to explicitly, on Mac anyway, probably the same on Windows, I've got to explicitly ask my operating system to show hidden files. And so now we can see the Git folder. And what I'm actually going to do is I'm just going to delete the repository. I'm going to start all over again because I didn't want that to be there. Okay, so we're back to square one. I want to go into here. Yeah, I want to go into here. And I want to take this out. Now let's go back to VS Code. So this is our, let's supposing this is our starting point now. This is my initial project structure, even though I've got some real code in there, but that's okay. Now, on the extreme left here, I was talking about VS Code's integration with Git. On the extreme left is what VS Code calls its activity bar. And this activity here is the version control or source control activity. You can see it popping up there. Now, if I click on that, if you like now, I'm in source control mode within VS Code. And it has spotted that there is no Git repository in this project at this stage. So it will create one for me if I click this. Clicking this is essentially the same as doing from the command line from here, typing git init. So I can do an awful lot of stuff without actually having to type any command. So let's do that. Let's create the repository. And what it's telling me now remember, you have to be in this activity area here. I go back to source control. That's the activity you're in when you're editing. And all of the, you see the U's beside everything here? Every file from Git's perspective is in an untracked state. And that makes sense because we haven't committed anything to the repository yet. So everything is untracked. And in fact, now I'm just gonna make some other changes because I want to undo that. So I'm gonna comment that out. And I also want to edit this guy. Make those all comments. Save that. Okay, everything is still untracked because there is nothing in my repository. And to do a staging, slightly ahead of myself now, so I'm just going to do this without explaining what I'm doing here now, just for a second. Okay, so we're at back at the stage now that I wanted to be at when I started demonstrating this, and suddenly there was something that I didn't want to have. So I'm back here. I've got a repository associated with this project, and the repository has some commits in it. Okay, I've just done one. That's fine. So it has knowledge. Git has knowledge of this file, this file. There's nothing in the test folder. It has knowledge of the git ignore, package lock, and package JSON. If I now go along and make some edits, which is where I was a while back, make some edits. And save that. The M here now tells me this file is in a modified state from Git's perspective. Previously, it was untracked for the reasons I explained, and also make some edits here. Oh dear. See. That's also in a modified state. And I'm going to pull in the test file. So obviously I've prepared this earlier on, so I'm just going to go back to, let's see. Okay, here's the file I want to bring into this is the actual project base folder here. I'm just going to pull this in. And I'm going to move it down into the test folder. When I go back to VS Code, I've got an untracked file and two modified files. Okay, so again, the risk of repeating myself, from Git's perspective, it has no previous copy of this file in the repository. It has previous copies of these two files, but you have made modifications to them since you committed them, and that is indeed the case. If I now want to, in order to put all of these changes into the repository, I now need to do two things. I need to stage them first and then commit them. If I go back to my slides. Okay, so I've confirmed this screenshot to you. Suppose we now want to stage all of the new and modified files. Now, the command to do that is the git add command. Again, you can type that from the command line, or you can get VS Code to do it for you. And the way you do it in VS Code is, you can see here, again, make sure you're in the source control activity. So I'll select that. And you can see a plus beside each file here. And and there's also a plus up here. So if I click this plus, all of these files now, essentially by clicking that plus, that is the equivalent of typing the git add command on the command line. And that's really what staging is from a VS Code's perspective. They haven't been committed yet, though. So that's staging. It's as simple as clicking the plus there, but from the command line, do I have it on from the command line? It would be the command git add -a. In fact, if I just do this for you, if I undo what I did there, Okay, I put them back to the way they were. Now over on the right here, I've typed the command git add -a. When I hit return, look at what happens on the left. Okay, they've all moved into the stage state. Okay, so I've done that. Typically, the next thing you do is you now commit them to the repository. And see, just before I do that, okay, we have that really. Finally, we commit them. Now, again, you can do the commit from the command line, or you can get VS Code to do it for you. When you commit, you've got to include a message with the commit, and the message is meant to explain why you made the changes that you made. Now, because my changes were somewhat random, I can't have a meaningful message, but there should be a that's my message. And to actually do the commit, I just simply click the commit button. Now, if we look at our working area is now what we say is it's clean, or it's completely in sync with the repository. Also, we would say that all of the files are in an unmodified state. Unmodified means you haven't made any changes to them since you committed, which I haven't. I've only just committed right now. Okay, so we commit, and in terms of the status of our working directory, which is really what we're talking about, what is the status of our working area or our working directory? Well, we can tell that it's clean, as I said. When I talk about status there, okay, we are checking the status by just looking at what's happening over here, but you can always, from the command line, you can type the command git status. And it will give you the necessary response. And in fact, if I just make some more edits, just make them random for now. And if I now do a git status from the command line on the right, this is how it tells you what the status of the working area is. And if you kind of read through it, it tallies with what you kind of see over here. So being able to read the response that you get back from the command line is important as well. And we won't always have this kind of VS Code assistance on the left. Some caveats to the above. Sometimes we don't want to include all of the modified files in a commit. So if I just demonstrate that, let's make an edit to here as well. Then let's not worry about the detail of the edit. Okay, let's check with Git. So I've got 3 modified files. Let's supposing I only want to stage these 2 and not the third one. Well, I can just stage them individually like that. So now there's 2 files that I've staged. Sorry, I want to undo that. There's 2 files that I've staged, and third file is just in a is unstaged, let's just say. And so if I do a commit now, let's not worry about the detail of the message. I commit, then my working directory isn't clean now at this stage, or isn't completely in sync with the repository, but that's okay. And the reason I would have maybe only staged 2 of the files and not all 3 of them, there has to be a reason why I would do that. And the reason should be that the 2 that you staged, the work or the changes contained within them somehow represent a unit of work, whereas the edits that have been made to this file here that I did not stage, that relates to a different unit of work. By unit of work, I mean you're working on a particular task, and maybe you've made a number of changes, and some of the files that you've changed aren't related to that particular task that you're working on. You were maybe trying to juggle 2 tasks at the same time, but you've completed 1 task. And so it's time now to do a staging and a commit of all of the work associated with that task. Either way, from a Git perspective, sometimes your working area is not going to be clean after you've done a commit, and I just demonstrated it there. So the git commit command itself, that's the command from the command line, git commit -m and the message. And the message is extremely important. At the very beginning there, I talked about what Git can do for you is it can tell you who changed the file, when they changed it, and where they changed it. And fourthly, it can tell you why they changed it. The why really comes from the commit message. The commit message is extremely important from a collaboration point of view, because it's the text of the commit message that should explain in a succinct way why the developer made the changes to the files that they changed. Git will tell you where you made the changes, but the commit message should explain why you made the changes. Typically, you're talking about fixing a bug, adding a new feature, refactoring a feature. State what it is in a succinct way, and those messages then are extremely useful to the other team members, because they can tell from them what is the nature of a particular commit, what was the nature of the work being carried out. Lots of organizations have very strict rules in terms of how you structure the commit message. That's how important they are. And at the very bottom there, okay, so some organizations have a commit strategy. The commit itself, it doesn't have to be limited to a string like this. You can actually put the commit message into a separate text file. And so that text file might have a format to it, which would be dictated by the organization that you're working for. So it can be quite detailed. It doesn't have to be limited to a simple string like this. We won't get into having attached text files containing our commit messages, but I am very keen that people think about the text of their commit messages when they're doing any kind of work for me. Not everything should be committed to the repository. Any files that are auto-generated, you never commit those to the repository. So, for example, if you're doing a Java project, when you compile your source code, generates the .class files, you never put those into a repository. Any files that are related to external libraries, third-party libraries, so that would be, for example, the node modules folder in our case, should never commit those to a repository. Any files that are related to the IDE that you're working with, or the editor that you're working with. So, for example, you may have seen a .vs code folder created by VS Code for you. That should not be committed to the repository. And the way you tell Git what files it should ignore, because those files are in the working area, like the node modules folder is in the working area, So you've got to tell Git to ignore them. And the way you do that is by using a special file called the .gitignore file. And so Git checks the contents of that file, it's just a simple text file, to determine what it should leave out when it's when you're doing a staging and committing. And that gitignore file, the way you express what you want to have omitted, there's a certain amount of regular expression syntax that you can use if you're familiar with regular expressions from other aspects of computer science. So there's kind of wildcard characters that you can use in your explanation for what should be ignored. And I'm just listing some of the parts of the regular expression syntax that we can use within our gitignore. Here's an example of a gitignore file. So what this is telling me is, well, first of all, sorry, if I go back to, I was mentioning it there on the previous slide. Yeah, any line in your gitignore that begins with slash means you're referring to a folder. So what this is telling Git is any files inside in this folder, do not commit those to the repository. In other words, ignore them. This is saying, it's fairly obvious really, any file in the base folder with a .log extension, the asterisk is obviously a wildcard character. We're also telling it to ignore everything inside in the public folder. When you've got an exclamation mark at the beginning of a file, beginning of a line in gitignore, that's essentially like a not character, a not operator. So here I'm saying ignore everything in the public folder, but here I'm saying do not ignore .html files in the public folder. They should be committed. And this one here then is saying anywhere you see temp in a file or folder name in any subfolder, just ignore that file or that folder from being committed. Right, as usual, I was hoping to be a little bit further, but I'm not. So I'm going to end the lecture there. I think we have enough covered, though, to complete tomorrow's lab. And so you'll get a chance to play around with Git, in particular inside in VS Code, which is what I'd like you to familiarize yourselves with. So I'm going to pause the lecture there, and I will talk to you at the beginning of tomorrow's lab. I'll just have a brief intro of the lab, and then I'll let you work away and I'll monitor it. But I'll monitor it remotely. Okay, thanks for tuning in, and I'll talk to you tomorrow morning.